more practice with A equals P times 1 plus I over N to the NT. This time we're going to, in this set of notes, we're going to see where this comes from. So if I do 8% compounded annually, after 1 year, I deposited $1,000. So I should have $1,000 plus 8% of $1,000. And notice I can have a common factor here of $1,000. So I'm going to just factor that out. And yes, you could turn it into 1.08, but I'm going to leave it separately because of problem 2. Okay, so after 2 years, we now have $1,080, and we get interest on that. And notice when we factor out the common factor here, we have 1,080 times 1 plus 0.08. But notice that 1,080 came from something. And then we multiply by another 1 plus 0.08. So we now have years worth. So, and that does come out, try it on your calculator. Okay, after 30 years, we just changed the exponent now that we know what we're doing. Okay, if I compound monthly, I don't get 8% every month. I get 0.8%. So after 1 month, I have $1,000 plus 0.8% worth of interest. Okay, after 30 years, notice that this one exponent here is 1 month, not 1 year. So if I want to do this for 30 years, I have to do 30 years worth of months. Okay, well, that was festive. How much difference does that make? If I look at the two numbers, does it make a lot of difference? Well, some, about $900. That's not chicken feed. You can buy a fair number of lattes for that. Okay, so if I have the formula, something startling happens if I make everything into as simple as possible except for n. So I take a limit as I compound more and more often, but I'm going to take $1, 100% interest, and 1 year. So just 1 plus 1 over n to the nth power. This one I don't even need a calculator for. 1 plus 1 to the 1 is 2. Okay, plugging in 365 where the 12 used to be, get 2.7146-ish. Plugging in 10,000. It's getting more and more, but not humongously more and more. The more often you compound, it actually settles down to a limit. What number is that? Oh, it's E. Okay, so E does rear its ugly little head in compound interest, and that's why we end up, one of the reasons we end up talking about natural logs and E so much, because it's continuously compounded interest. It's the limit process.